Okay, topic 3.4, integration by parts, question 3D. I've got to integrate sine squared of 8z times e to the power of z. Now, inside in your formula book, there's a special formula here that it says if I have sine squared a, I can write that as a half times 1 minus cos 2a. I'm not integrating or anything, it's just an identity that says that if I have a sine squared of an angle, this is another way of writing it. That's a very handy thing to do, is to rewrite our equation using this first, because it prevents us having to deal with the sine squared, which we can do. We did it in the last example. Okay, so we could, what we could do is we could factorize out our e to the power of z, kind of leaving us with 1 minus cos of 16z over 16z, and then try and turn it back into squares if you wanted. That's what your teacher did, but to be honest with you, it's kind of overly complicated. Last thing I'm just going to do is multiply in my half here, so it's e to the power of z over 2 minus, now remember we're multiplying by a half, you'd be multiplying the bottom line by 2, so minus e to the power of z cos of 16z and 257 by 2 over 514, and the same thing here, we have our minus, so that's minus 16 e to the power of z sine 16z all over 514 as well, and then forget your plus c. So it's a complex integral, okay? But it just gets very, very messy and long. This speeds the process up a bit. So I rewrite it. So sine squared 8z, so that'll be a half 1 minus the cosine, and it's of 2 times whatever angle. So I've got 8z here, so it's 2 times 8z, which is 16z. Make sure I have all my brackets in place. And I'm multiplying that, of course, then by e to the power of z dz. So the half is multiplying everything here. So I'm going to pop my half out in front. So it'll be a half times 1 minus the cosine of 16z, all multiplied by e to the power of z dz. And now I'm going to multiply my e to the power of z in. So it's a half times the integral of e to the power of z minus e to the power of z cosine of 16z, and all that's dz. Okay, so I've got integration here. Now I have to integrate the e to the power of z, and then I also have to integrate the minus e to the power of z cos 16z to finish up. E to the power of z, that's no problem. But of course, this is a bit of a problem integrating this here. So what I'm going to do is I'm going to integrate that separately out to the side for the moment, and I'm going to do it using integration by parts. So I have to integrate that part of it. I'm only interested in the e to the power of z cos 16z. I'm leaving the minus behind me. I'll bring that back in later. So u equals cosine of 16z. I'm picking that for u purely because it's easier for me to integrate it, or to differentiate it, than integrate it. So du dz, so the derivative of cosine is minus sine, and the derivative of 16z is 16. So minus 16 sine of 16z. And then bring my dz over. So I've got minus 16 sine of 16z dz. Excellent. Okay. Now, therefore, I must let my dv equals my e to the power of z. So the integral of dv is still e to the power of z. And of course, we can call the integral of dv just v, e to the power of z. So my 4 important parts. Now, just a health warning here. This integral, we're going to have to end up doing integration by parts twice to end up solving this fella. Alright, let's apply our formula here, so to the side. So we've got our integral of u dv is equal to uv minus the integral of v du. So the integral of u dv is the thing we're trying to do. E to the power of z cosine of 16z That's equal to uv. So that's cos of 16z by e to the power of z. I'll write it as e to the power of z cos of 16z minus the integral of v du. So v is e to the power of z, and du is minus 16 times 16 to the power of z. Now when I do that, the minus 16 is going to be multiplying everything, so I'm going to pop it outside in front. So when I bring it outside, the minus 16 comes outside, but minus minus is going to give me a plus. So I have my plus 16 out in front there. E to the power of z sine of 16 z dz. Okay. All right. So still there. Still got a problem here. This fella here is going to cause me an issue because I can't integrate him. So I'm going to try integrate him by parts again. So taking this part here. So the integral of what am I doing here? The integral of, and I'll leave my 16 behind, I'll put it back in a minute, e to the power of z sine of 16z. So let's try our integration by parts again. I've got my dz. U equals sine of 16z. So du dz equals, so the derivative of sine is cos, and the derivative of 16z is 16. So 16 cos of 16z. All right. So du equals 16 cos of 16z dz. Now we've got our dv, and our dv is equal to e to the power of z. So the integral of dv is equal to e to the power of z. And that means we can write v as e to the power of z. So things will start slowly wrapping up now and coming together. We're at the end of our tricky integration. We just need to start working our way back, putting them together. So at this part here, I was looking for the integral of e to the power of z cos of 16z. And I saw that that's equal to e to the power of z cos of 16z plus 16 times the integral of e to the power of z sine 16z. But I need to put that integral together there now. So that integral, I'll be following my uv minus v du. So uv, so e to the power of z, e to the power of z, uv sine of 16z minus the integral of, now it's going to be v du. So v du is e to the power of z by 16 cos 16z dz. Now that 16 will be multiplying everything, so I'm going to pop him outside here. Okay, so that'll give me e to the power of z cos of 16z dz. Okay, so it doesn't make my work a whole lot easier, except for the fact that I notice, I'm just going to get rid of some of my writing here at the side because it's just making things a little messy to look at. 16z dz. Okay, I'll notice here that I have e to the power of z cosine 16z, and I also have that same integral here. So I think you'll know the trick we're going to try and pull now in a second. So first thing I'm going to do is get rid of my brackets. So I'm going to multiply my 16 in here. So I've got the integral of e to the power of z cos 16z equals e to the power of z cos 16z. Now 16 multiplies the first thing, so it's going to be plus 16 e to the power of z sine of 16z. And then I have 16 by minus 16. 16 by minus 16. Minus 256 times the integral of e to the power of z cosine of 16z dz. So as we said, I've got minus 256 times the integral here, and I've got the exact same integral here. So if I bring minus 256 over, it becomes plus 256 times the integral. So the integral plus 256 times the integral is 257 times the integral. Is equal to e to the power of z cosine of 16z plus 16 e to the power of z sine 16z. Okay, so finally, to get my integral of e to the power of z cos 16z, I bring my 257, which is multiplying, over to divide. E to the power of z cos 16z over 257 plus 16 e to the power of z sine 16z over 257. Okay, so now I have this thing here integrated. Why did I want that? So back now again, we're backtracking. I wanted it here. So inside in here, I have a half times the integral of e to the power of z minus e to the power of z cos 16z. So that's a half times. Now, I know the integral of e to the power of z, it's just e to the power of z, that's grand. And then minus, now, what was the integral of this fella? Well, we just found him out here now a second ago. It's all of this guy here. E to the power of z cos 16z over 257, e to the power of z cos 16z over 257, plus 16 e to the power of z sine 16z over 257. So plus, my brain has stopped working, 16 e to the power of z sine 16z plus, and again it stopped working, 16 e to the power of z sine 16z all over 257. Okay, so that is more or less our integral plus c. Let's see if we can tidy it up just a little. Okay, sorry, it's run into a few technical difficulties there and it deleted it a second ago. So look, all I did to tidy it up was multiply in my half. So half times e to the power of z is e to the power of z over 2. Now I've got minus everything in the bracket. So this will be minus and this will become minus. But the half is also multiplying those. So remember, multiplying by half, it's the 257. That'll be multiplied by 2, giving me 514 and 514 plus c. Now, other options for this is to factorize out the half and factorize out your e to the power of z and try get an expression that looks like a half times 1 minus the cos of an angle, and you can use that to bring back in sine squares, which is kind of what your teacher did there. And then she used the sine 2a formula here, but it's a bit overly complicated, to be honest with you, and there's no need for it. So you're absolutely fine with this integral here, or this one.